Okay, welcome to the Chapter 7 review. The Chapter 7 test will be tomorrow, Friday. So here's the review worksheet. We'll go over the methods for setting up these problems and solving them. The first three, or the first problem actually, asks you to find the geometric mean for the following pairs. So the geometric mean, remember, is A is to X as X is to B, where X is the geometric mean. Okay, that means we have A and B. So 11 is to X as X is to 17. When you cross multiply, you're going to get X squared equals 187. So therefore, this X is equal to the square root of 187. And you can't simplify that. You can just leave that one as it is. The next one, 5 is to X as X is to 15. Again, when you cross multiply, you're going to get that X squared is equal to 75. So X equals the square root of 75. Now you want to put that in simplest radical form. So you want to break 75 down into a perfect square and a non-perfect square. So that would be the square root of 25 times the square root of 3. So therefore X is equal to 5 root 3. That is simplest radical form, and that's how you should write your answers. C then is 9 is to X as X is to 81. You cross multiply, you get X squared is equal to 729. The first thing you want to try is putting 729 in your calculator, taking the square root of that to see if it's a perfect square. 729 is a perfect square, so X for that is equal to 27. So again, here is the general formula for the geometric mean. X is the geometric mean. So when you're given two numbers and asked to find the geometric mean, you substitute those in as A and B, cross multiply, take the square root, and then simplify that. The next question now says the geometric mean and a side are given. Find the length of the other side. So again, this is A is to X as X is to B. But in this case, we're given the geometric mean. So that means when we set up our little proportion, 4 goes in place of the X because it is the geometric mean. 2 can be substituted in for either A or B, and the other you leave as the variable. When you cross multiply, you get 2B equals 16. Divide by 2, so B equals 8. 2B says 11 is the geometric mean. Again, set up your proportion. 11 is the geometric mean, so it goes where the x's would be. And then it says between 121 and what number. So you can substitute 121 in for A or B. It doesn't matter. When you cross multiply, you get 121. A equals 121, so A equals 1. C, it says 8 is the geometric mean. So again, start your proportion. 8 is the geometric mean, so it goes in place of X between 4 and some number. Doesn't matter which section you put the 4 in. Cross multiply, you get 4B is equal to 64, so B is equal to 16. Okay, two types of problems like that involving the geometric mean. One, you're given A and B, and you need to find the geometric mean. That's like problem 1. And then the second is you're given the geometric mean, and you need to find either A or B. Okay, number 3. Penelope is 5 feet tall. So here's Penelope, lovely little stick figure. She is 5 feet tall. It says at 3 in the afternoon, her shadow is 7 feet long. At the same time, the office building she works in casts a 20-foot shadow. How tall is the building Penelope works in? So we can set up some similar, we have similar triangles here, actually, similar right triangles. So we can say 5 is to 7 as x is to 20. Cross multiply, you get 7x equals 100. So x is equal to 14.29 feet, or 14 feet 3.5 inches. Number 4, remember these are the geometric means. If you don't remember that how to find x, y, and z, you can set up those triangles. Remember we have 3 similar triangles. This is triangle 1. It has a side of c, a long leg of x, a hypotenuse of y. Then we have the second triangle, number 2. That's the middle size triangle. It has a short leg of x, a long leg of 42, a long leg of 42, and a hypotenuse of z. Then you have the largest triangle, the original triangle, which has a short leg of y, a hypotenuse of 48, and a long leg of z. So when you want to find the value of a variable, you're looking for the 2 triangles in which that variable occurs. For example, if you're looking for x, that occurs in the first triangle and the second triangle. And if you look at which leg x represents here, it's the long leg, and here it is the short leg. So we're going to be comparing to find x, the long leg and the short leg. So in the first triangle, I'm going to take the short leg, 6 is to the long leg x, as the short leg x is to the long leg, which is 42. You could also think of that as the short leg is to the short leg as the long leg is to the long leg. When you cross multiply, you're going to get x squared equals 252. So x is equal to 6 root 7. When you're looking to find z, you're going to compare the medium-sized triangle and the largest triangle, and you're looking at the hypotenuse for this side and then the long leg for this side. So you're going to compare the long leg. So the long leg 42 is to the long leg z, as the hypotenuse z is to the hypotenuse 48. Cross multiply, and you're going to get z squared is equal to 2016. Simplified radical form, z is equal to 12 square root of 14. Last one you want to find is then y. Y appears in the smallest and the largest triangle. In the smallest, it's the hypotenuse, and in the largest, it's the short leg. So we're going to be comparing the short leg, 6 is to the short leg y, as the hypotenuse y is to the hypotenuse 48. When you cross multiply, you're going to get y squared is equal to 288. y is equal to then the square root of 288, or 12 root 2. Now, if you're concerned about how to simplify those radicals when you get to this point where you have x is equal to the square root of 252, start dividing 252 by perfect squares, 4, 9, 16, 25, and you'll be able to break that down into a perfect square and a non-perfect square. For example, let's look at this one. Y is equal to the square root of 288. That becomes the square root of 144 times the square root of 2. Square root of 144 is 12 root 2. Let's look at B as well. Sorry, these are a little hard to see. I'm going to draw those 3 triangles, 1, 2, and then the original 3. So I have 10, y, and x. Then the medium-sized triangle, which is going to be x, 50, and z. And finally the last triangle, which is going to be y, z, and 60. You're looking to solve for x. Look for the 2 triangles that contain an x, and look at the sides that they represent. So for x, we're talking about the short leg and the long leg. So the short leg and the long leg. I have 10 is to x as x is to 50. Short leg is to short leg as long leg is to long leg. Cross multiply and you get x squared equals 500. So in simplest radical form, you're going to make that x is equal to the square root of 500. X is equal to then the square root of 100 times the square root of 5. So x is equal to 10 root 5. Next, you want to find y. So you have y's here. They represent the hypotenuse and the short leg. So we're going to set up our proportion using the hypotenuse and the short leg. The short leg, 10, is to the short leg y, as the hypotenuse y is to the hypotenuse 60. Cross multiply, you get y squared equals 600. So y equals the square root of 600. Y equals the square root of 100. Square root of 6. So y is equal to 10 root 6. Finally, you're going to look at z. So z is the second triangle and the third triangle, and it uses the long leg and the hypotenuse. So set up your ratio using the long leg and hypotenuse. The long leg 50 is to the long leg z, as the hypotenuse z is to 60. Cross multiply, z squared equals 3,000, so z equals the square root of 3,000. You can break that down into the square root of 100 and the square root of 30. Square root of 100 is 10 root 30. Okay, so those are your answers for x, y, and z. And you should expect to see a problem very similar to that tomorrow on the test. Okay, solve the following proportions. Remember, to solve a proportion, you're going to cross multiply. So here I have 5 times 2x plus 8 is equal to 3 times x minus 4. Use the distributive property, 5 times 2x and 5 times 8. And that will give you 10x plus 40. On the right-hand side, 3 times x and 3 times negative 4. And that will give you 3x minus 12. To solve this, You're going to subtract 3x from both sides. When you do that, if you look at these two, they cancel. So I have 7x plus 40 equals negative 12. Subtract the 40 from both sides. And you will get that 7x is equal to negative 52. Divide both sides by 7, so x is equal to negative 52 sevenths. Number 6, this one's a little tougher because you're going to get a quadratic and you're going to have to factor it. So when you cross multiply here, you have x minus 4 times x plus 2 is equal to 2x times x minus 4. Remember, you're going to FOIL. Don't forget, on the left-hand side, you're going to FOIL. X times x gives you x squared. X times 2 plus 2x. Negative 4 times x minus 4x. And negative 4 times 2 minus 8. On the right-hand side, you're going to use the distributive property. So 2x times x gives you 2x squared. 2x times negative 4 gives me minus 8x. Now, before you start moving things around, make sure you combine like terms on the left-hand side here. So I have x squared minus 2x minus 8 equals 2x squared minus 8x. Now remember, when you have a quadratic, that means you have an equation with the power on x is 2. It's squared. That's a quadratic. So you want to get everything on one side of the equation. I've told you in class it's easier if your leading coefficient is positive. So I'm going to subtract the x squared from both sides. So I get minus 2x minus 8 equals x squared minus 8x. Then I'm going to add the 2x to both sides. Minus 8 equals x squared minus 6x, and then I'll add the 8 to both sides. So x squared minus 6x plus 8 equals 0. Again, you can do that all at once if you see it. If it's too confusing, take your time and write each step. So now I have x squared minus 6x plus 8 equals 0. This is an easy one to use guess and check with. So I have x squared. There's only one way for me to multiply two first terms together and get an x squared, and that's x times x. Now when I look, the sign on 8 is positive. That tells me that these are either both positive or both negative. So I go to the second term and I see that that's negative. That tells me both of these must be negative. So what multiplies to 8 and adds to 6? 4 and 2. So FOIL that back to make sure you have the right factors. So you have x squared minus 2x minus 4x plus 8 equals 0. X squared minus 6x plus 8 equals 0. Yes, those are the correct factors. So now the question is, what values of x make that true? When x minus 4 is equal to 0, or when x minus 2 is equal to 0. So when x is equal to 4 and x is equal to 2. If you substitute those two values into the original equation, you will find that that equation is true. There will be a problem like that, similar to that, on the quiz. Number 7 is an extended proportion. So you have to solve this extended proportion. Remember, you can't solve it the way it is. You have to break it into two separate equations. Choose the equation with only numbers in it. So I have 1/3 is equal to, then choose one of the other equations. I'll choose the one with x first. So I have 4 times x minus 1 over 12. Then for the second one, again, you're going to use that 1/3, and you're going to set that equal to the ratio with a y. So that's 12 over 6y. So I have 1/3 is equal to 4x minus 4 over 12. Cross multiply. 12 is equal to 12x minus 12. Add 12 to both sides. You're going to get 12x equals 24. Divide by 12. X is equal to 2. For the y, cross multiply, you get 6y is equal to 36. Divide by 6. Y is equal to 6. There are the solutions for x and y in your extended proportion. Okay? Let's look at number 8. It says set up a proportion and solve for the variables. OP bisects, so this ray bisects angle UPT. Okay, we had a theorem for this. It said that if a ray bisects the angle, it divides the hypotenuse proportionally with the legs. So therefore, the leg UP, 4x minus 2, is to the segment 7 as the length PT, which is x plus 2, is to 3. Cross multiply, you have 3 times 4x minus 2 is equal to 7 times x plus 2. 12x minus 6 is equal to 7x plus 14. Subtract the 7x from both sides, add the 6 to both sides, and you should get 5x is equal to 20, so x is equal to 4. Number 9 says set up a proportion and solve for the variables. Here you are given that these are parallel. AB is parallel to CD. CD is parallel to EF. So remember, that divides these proportionally so that AC is to BD as CE is to DF. So I can set up a proportion. AC is x, BD is 3, CE is x plus 4, and DF is 5. Again, cross multiply. 5x is equal to 3 times x plus 4. So 5x is equal to 3x plus 12. Subtract the 3x. You'll get 2x is equal to 12. So x is equal to 6. Number 10, set up a proportion and solve for the variable. So now we have similar triangles. And you should be very careful when you set up this problem. There's a really common mistake. When you look at these two triangles, the first one, I'm going to outline this in red. And actually, I'm going to redraw that triangle. So I have this triangle, which has a side length of 9 and a base of x plus 3. Then I have this triangle, ADE. Okay, when we look at the side of that triangle, the base is x plus 5. That's the easy part. The common mistake is to forget that the length of AD is the sum of 9 and x. So this is actually 9 plus x. So be careful, don't just write x there. It's the sum because it's similar triangles and it's the entire length. So now I can set up my proportion. 9 is to x plus 3 as 9 plus x is to x plus 5. I can cross multiply now. I get 9 times x plus 5 is equal to x plus 3, and I'm just going to rewrite this as x plus 9. I'm going to have to FOIL that, so it looks like I'm going to have another one that I'm going to have to factor. On the left-hand side, I have the distributive property, so 9x plus 45. On the right-hand side, I'm going to have to FOIL, so I'm multiplying the first, the outer, the inner, and the last. That would give me x squared plus 9x plus 3x plus 27. Combine like terms first so you don't lose track of anything. Make it as simple as you can. Make it look as simple as possible. So I have 9x plus 45 equals x squared plus 12x plus 27. Now I want my leading coefficient again to be positive, so I'm going to subtract the 9x from both sides, and I'll subtract the 45 from both sides. On this side I have a 0, then I will have an x squared plus 3x minus 18. So now I want to factor this. Again, I'm going to try guess and check. See if I can make that work. So I set up my parentheses because I know I'm going to get two binomials. In order to get x squared, I'm going to take x times x. Now, when I look at the last sign, the sign on the third term, that's negative. So that tells me one of these is positive and one of these is negative. I have to figure out which is which. So I asked myself, what are the factors of 18, negative 18? What can I multiply together to get negative 18? Well, I could do negative 1 and 18, or 1 and negative 18. I can do negative 2 and 9. I can do 2 and negative 9. I can do negative 3 and 6. I can do 3 and negative 6. And that should cover all the combinations, I believe. So which one do I want to choose? Well, what multiplies to negative 18 but adds to positive 3? So what adds to positive 3 is going to be this combination of negative 3 and positive 6. So I'll put those values in, minus 3 and plus 6. Now when I FOIL this back, do I get what I started with before I started factoring? Do I get this back? So I have x times x is x squared, x times 6 is plus 6x, negative 3 times x gives me minus 3x, negative 3 times 6 gives me minus 18. Combine like terms, I have x squared plus 3x minus 18 equals 0. So I've factored it correctly. That means I need to take those factors, x minus 3 and x plus 6 equals 0. So when x minus 3 is equal to 0, or when x plus 6 is equal to 0, I'll find the values of x that will make that true. So when x is equal to 3, when x is equal to negative 6. So those are the solutions to number 10, except one thing. We have to think about one thing when we look at this. In factored form, I get that x is a negative 6, but when I go back to the original problem, if I try to substitute a negative 6 in for the value of x, I will have a negative length. I can't have a negative length, so therefore -6 cannot be an answer. The only answer is x is equal to 3. So you might factor it in and you might get two values of x that would make the proportion true, but if one of them's negative and you're talking about a length, that's not a valid answer, so you want to cross that one out. Okay, now we have a few word problems. It says, Myra's meatloaf uses 4 pounds of hamburger to feed 6 people. How many pounds of hamburger will be used to feed 15? So the ratio is 4 people, or 4 pounds to 6 people. So you need X pounds to feed 15 people. So you're talking about pounds to people. Cross multiply, you get 60 equals 6x. Divide by 6, x is equal to 10. Number 12, if 3 hens lay 10 eggs in 5 days, how many eggs will 3 hens lay in 20 days? So there's a little bit of extra information in there, but it just helps you understand that you're comparing something alike. 3 hens and 3 hens. So we're comparing eggs to days. So I have 10 eggs in 5 days as X eggs in 20 days. Cross multiply, you get 200 equals 5x, so x is equal to 40. So 40 eggs in 20 days. 13 is similar. If 8 hens lay 14 eggs in 6 days, then how many eggs will 24 hens lay in 6 days? So now you have to think about that. What is alike? The 6 days is alike. So we must be comparing hens to eggs. So I have 8 hens lay 14 eggs. How many eggs will 24 hens lay in 6 days? So 8 hens to 14 eggs, 24 hens to X eggs. Cross multiply, you get 8x is equal to 336, so x is equal to 42. So 42 eggs by 24 hens in 6 days. And the last problem, if it costs $200,000 to build a sidewalk around a rectangular field whose dimensions are 200 yards by 800 yards, how much will it cost to have a sidewalk installed around a rectangular lot that is 125 by 170 feet? So when you look at this, you kind of have to think about this for a little bit. You're looking for the cost. So how much will it cost? I think I have to change something. This should be a sidewalk. That doesn't make sense there. That should be a sidewalk. Sorry about that. Okay, so I'm looking for the cost. So I'm going to be comparing the cost to the perimeter. Okay, so when I look at this, I'm looking at a sidewalk around a rectangular field. So I have a rectangular field that has dimensions of 200 by 800. So the perimeter of this is going to be, perimeter is equal to 2,000 yards. So I have 2,000 yards. Now when I look at the next one, it's in feet, so that's a little bit of a problem. I'm going to want to change that. Either multiply or divide the yards, or multiply the feet. Let's change this from yards to feet. So the perimeter is equal to 6,000 feet. We want to compare like measures. So now the perimeter of the rectangular lot is 125 and 170. So the perimeter of this in feet would be 590 feet. So again, we're comparing cost to the perimeter. So I have the cost of $200,000 over 6,000 feet is equal to the cost X of the sidewalk that surrounds the smaller rectangle, which is 590 feet. So I multiply 200,000 by 590 and then divide by 6,000, and I get $19,667. So the cost of that sidewalk would be $19,667 when you cross multiply. Okay, the test is tomorrow. The questions on the test are very similar to the questions that you saw on this review sheet. Take a few minutes, spend some time working on the review sheet and looking at the problems you don't understand. Try to get some clarification. Good luck, and I'll see you tomorrow.